Alright, so we have a pendulum problem here, and in the question they tell us that the mass of the pendulum is going to be 5.50 kilograms, and the starting position's height is going to be 6.25 meters from its lowest position, as seen in the diagram here. And the question's asking us to find what the velocity will be when it reaches its maximum speed. And it will reach its maximum speed when it's hanging at its lowest position, because all of the gravitational energies from position 1 is going to be transferred into kinetic energy here, making it it's going to have the highest velocity. And this is because, according to the law of conservation of energy, energy cannot be created nor destroyed, meaning that all of the energy at position 1 is going to be equal to the energy at position 2 as well. So ET1 is equal to EG1 plus EK1, so gravitational energy and kinetic energy. But if you look a bit closer, you'll realize that when it's hanging at position 1, it's not moving yet, meaning it's going to have no velocity. That means that there's going to be no kinetic energy at that position. There will be gravitational energy, however, because it does have a height, meaning that gravity will pull it down, meaning it will have potential energy. When you look at ET2, it's similar, but it's different, where there's going to be no gravitational energy because it's at its lowest point and there's not going to be a height. There will be kinetic energy, however, because it has a velocity and it's moving. So once you realize that, you can actually zero out the EK1 and the EG2 and zero them out to simplify to gravitational energy 1 plus or is equal to the kinetic energy of 2. That can be further broken down using the equations from your equation sheet into mass times acceleration due to gravity times height of 1 is equal to 1/2 of the mass times velocity 2 squared. But what we're isolating, or what we're looking for, is the V2, so we're going to isolate for that into mass times acceleration times height 1 divided by the half of mass, all square rooted. And if you realize, you can actually notice that there's mass on the top and the bottom of this fraction, meaning you can cancel them out because there's no addition or subtraction signs interfering in the way of the numerator or the denominator. So once you realize that, you can sub in your values and you'll end up getting 11.0736 meters per second. But the question has 3 sig figs as seen here and here, so it's going to be about 11.1 meters per second. Therefore, the maximum speed will be 11.1 meters per second.